Good day, we are the Group 7, and today we will be explaining the function and the process of the condition of a traffic light with a blinking yellow light system. So, when the I0.0 push button is pressed, the traffic light should normally light up a green light for 3 seconds, followed by a yellow light for 2 seconds, then a red light for 3 seconds. The cycle should then continue to light up like green, yellow, red, and so on. So here is how we can create the ladder diagram for the given condition using a macro PLC. So, in the first rung, we use the ENT00 or the enter00 instruction to read the I0.0 push button input, which is a normally closed, to the RAM01 output. The ENT06 instruction is also normally closed and is used to prevent RAM01 output from being activated unless the I0.0 push button is pressed. The AND function is used to ensure that both conditions are met before the RAM00 output is activated. The output RAM00 is connected to the outside 00 instruction, which activates the green light signal. The signal is then connected to a timer of 3 seconds, which is latched using cell 00 instruction. Another latch instruction is the T0N2 and it is used to maintain the green light signal for the duration of the timer. In the second rung, the T0N instruction is used to read the SAL02 output, which is normally closed ENT06 and normally closed RAM00. This is to ensure that RAM01 output is reset and that the green light signal is turned off before the next signal is activated. The output RAM00 is connected to the out RAM01 instruction, which activates the yellow light signal. The signal is then connected to a timer of 2 seconds, which is latched using the RAM01 instruction. Next, in the third rung, the T01 instructions is used to read the SAL01 output, which is a normally closed ENT06 and normally closed RAM00. This is to ensure that the RAM01 output is reset and that the yellow light signal is turned off before the next signal is activated. The output of the RAM01 is connected to the OutCell02 instructions, which activates the next light, which is the red signal light. This signal is then connected to a timer of 3 seconds, which is latched using the SAL02 instruction. In the fourth rung, the ENT05 instruction is used to read the I0.5 push button input, which is normally closed to the ENT06 instructions. This is to ensure that the yellow light or the yellow blinking light signal is only activated when the I0.5 push button is pressed. The output of the ENT06 is connected to the OutRAM 00 instruction, which activates the yellow blinking light signal. The signal is then latched using the RAM00 instruction. In the fifth rung, the RAM00 output is connected to the normally closed T0N04 or the timer on delay number 4 instruction. This is to ensure that the yellow blinking light signal is turned off after 1 second. The output of the T0N04 is connected to the T0N3 or the timer on delay number 3 instruction used in the Macro PLC, which is used to maintain the signal for the duration of the timer. In the sixth rung, the T0N3 or the timer on delay number 3 instructions output is connected to the OutRAM 02 instruction. Next, in the seventh rung of the Macro PLC, the RAM01 and RAM02 is in the OR function, connected to the output, which out sal 01. This is to ensure that the program will be executed wisely and the system will not be confused. So, when the I0.6 push button is pressed, the traffic light will be reset and will start the cycle once the start push button I0.0 is pressed. Now, I will run the traffic light signal with a blinking light system condition. So, as you can see in the video, the use of PLCs in the traffic light control can help to bridge the gap between the simulation and reality. By programming a simulation of a traffic light system using a PLC, engineers and designers can test and refine their design before implementing them in the real world. This can help to identify potential issues or areas for improvements and innovation, leading to a more efficient and effective traffic control system in our environment.